Hey everybody, how you doing? Mr. Troy here. What I've got for you today is a video that is reviewing the trig that you hopefully learned at some point in a geometry class. Now, there's going to be a lot of stuff presented here, and I'm going to give you a lot of time where you can ask questions because there's quite a bit of material to cover. Okay, so please make sure if you've got questions, you're asking them. Cool? All right, it's time for math with Mr. Troy. All right, we're going to start in a slightly different way today than we normally do because this is review. What I want you to do is I want you to pause the video and to the best of your ability, try to solve these two problems. Okay, ready? You going to pause? You sure? Okay, pause the video, solve those problems. All right, here's the answer to the first problem. And here's the answer to the second problem. Make sure you ask questions about those if you've got them when it comes time for our Google Meet today. Cool. All right, so we move on. We're going to start by talking about the 6 trigonometric functions which are just defined for you. Here they are. Whoa! Now I'm over here. Hey, cut that out. No, you cut that out. Should I cut this part out of the video? Nah. Okay, so this is the point where we learn our first really basic trigonometric identities. They're called the reciprocal identities. Now, all the reciprocal identities are saying is that the sine of an angle is the reciprocal of the cosecant of an angle. The cosecant is defined as the hypotenuse over the opposite, which is the reciprocal of the sine. The cosine is the reciprocal of the secant, and the tangent is the reciprocal of the cotangent. For some of you, those bottom 3, 1, 2, 3, are going to be new. That's okay. It's just sometimes we don't want the hypotenuse to be in the denominator, or sometimes we want to talk about the adjacent over the opposite instead of the opposite over the adjacent. No big deal. All right, moving on. Okay, so we are asked to find the 6 trig functions for the angle theta. So in order, those 6 trig functions are the sine, the cosine, and the tangent. SOHCAHTOA are the ones you already knew. And then their reciprocals, which are the cosecant, the secant, and the cotangent. The way that I remember which ones match up, and this is kind of silly, but the way that I remember is that each pair has one that starts with C. So it's not cosine and cosecant that go together, because only one starts with C in each pair. When we start, we could do, say, the cosine and the secant immediately, because we know both the adjacent side and the hypotenuse. So cosine 7/9, secant 9/7, it's reciprocal. But for anything involving the opposite, we need to figure out this other side. And the way we figure out that other side is using our good friend Pythagoras. 7 squared plus the opposite squared equals 9 squared. That makes sense. You remember the Pythagorean theorem from last year, right? Good. So if we follow that through, we get that the opposite is 4 root 2. And there's no problem with 4 root 2. We're just going to remember that if that ends up in a denominator, we are going to have to rationalize it. So the sine is the opposite over the hypotenuse. That's 4 root 2 over 9. And the tangent is the opposite over the adjacent. That is 4 root 2 over 7. No problems there. When we go, however, to take the reciprocal of those, we are going to want to be careful, and we're going to want to make sure that we rationalize our denominator. So we can't just say 9 over 4 root 2. We have to rationalize that denominator, and we have to say 9 root 2 over 8, multiplying by root 2 over root 2 on both sides. Okay. We can start by saying 7 over 4 root 2, but we have to rationalize our denominator, and we have to say 7 root 2 over 8. Okay? Let me know if you have any questions. For some of you, those reciprocal functions are new, so just make sure you ask if you've got questions. Speaking of things that might be new, we've got some vocab that might be new to you. So pause the video and read this. Here is some of the vocab that might be new to you. So let me explain what this problem is asking. It's saying that this point right here is on the terminal side of an angle. So that there is some angle like that. And we're being asked, hey, what's the sine of that? What's the cosine of that? What's the cosecant of that? Etc. This angle in standard position would have an adjacent of 3, an opposite of 4, and then by the Pythagorean theorem, a hypotenuse of 5. So this is pretty simple. The sine is 4/5. The cosecant is 5/4. The cosine is 3/5. The secant is 5/3. The tangent is 4/3. And the cotangent is 3/4. Cool. Should be pretty straightforward. Okay. I want you to pause the video and I want you to do the next one on your own, but keep this thought in the back of your mind. Ask yourself, does the -8 matter? Is it the same as 8, or does the -8 matter? All right, pause the video, give that one a try. So I labeled part of the diagram for you, and you can see that I labeled it on both sides. You might be asking yourself, am I talking about this angle, or am I talking about this angle? And it actually doesn't matter. Those both have what would be called the same reference angle. We would need to use the sine inverse or the cosine inverse or any one of these inverses, and those are all buttons on your calculator. But those angle measurements, whether it's the positive one or the negative one, are going to have the same sine, the same cosine, etc. Now, in order to properly place this in a quadrant, the -8 is going to matter. So what that means is that the x and y values are going to be directed distances. The hypotenuse is always going to be a positive number. We're going to think of that as like the radius of a circle, so that's always going to be positive. But the x and y are going to be directed distances. All right, go ahead and finish this one up. So there are your answers. Hopefully those match up with what you were thinking. Of course, if I made a mistake, let me know in the comments. Cool. So we can generalize this out to any xy coordinate. So if I place a random point, x comma y, the hypotenuse is going to be the square root of x squared plus y squared. Think about the Pythagorean theorem. Here's the hypotenuse. So our sine is going to be y over the square root of x squared plus y squared. And the cosecant is going to be the reciprocal of that. The cosine is going to be, well, gosh, this is all getting kind of complicated. So to save ourselves some time, instead of having to write that over and over again and think about rationalizing our denominator, sometimes what we do is we just simplify that to r. Now, why r? Because it's going to be the radius of a circle. So the cosine is going to be x over r, and the secant is going to be r over x. The tangent is going to be y over x, and the cotangent is going to be x over y. Because of that, we can tell in each quadrant if the sine is going to be positive or negative, if the cosine is going to be positive or negative, etc. The way that we remember this is by using a mnemonic all students take calculus. And what that mnemonic tells you is that all of them are positive in the first quadrant, the sine is positive in the second quadrant, the tangent is positive in the third quadrant, and the cosine is positive in the fourth quadrant. Okay, can you see where that mnemonic comes in? Cool. Now, our final thing here is just a brush up on our special right triangles. We have a 45, 45, 90 triangle, and a 30, 60, 90 triangle. So recall that there is a relationship of 1 to 1 to the square root of 2 in a 45, 45, 90 triangle, and 1 to root 3 to 2 in a 30, 60, 90 triangle. Another thing that's useful, though, is to go the opposite direction. So what if instead of having the leg of your 45, 45, 90 triangle be 1, the hypotenuse is 1? Well, in that case, the leg would be 1 over the square root of 2, which is root 2 over 2. What if the hypotenuse of your 30, 60, 90 triangle was 1? Well, this would be 1/2, because remember the hypotenuse is always twice that shortest leg, which would make the longest leg root 3 over 2. In the Google Classroom, I'm going to put a bunch of stuff in there that's going to be optional that you can do if you need extra practice. Everyone's coming at trig in a different place, so don't worry if some of this stuff is a challenge, or if you need extra practice, or if you need extra help, or if you need to ask questions. There'll be plenty of time for that. All right, cool. Hey everybody, I just want to make sure that you guys hang in there. If you haven't already, bake yourself a sourdough bread. Cool. See ya.